I think this is a good idea because it's eventually, especially in the era of generative AI. How do we know if we actually learn anything from this course? Because if the final exam is just 1%, we have a lot of group projects, and we have all kinds of assignments, then people ended up, like, during the pandemic, that's what I heard. During the pandemic, that everybody's working from home, everyone is doing the courses online, then it's very hard for people to assess. It's very hard for the school to assess the students, their ability to actually code. So the good thing about this course is that we're going to have a 60% final exam, so we'll try our best to prepare you for that. And the final exam, it will be mostly coding-based and with some concepts and theory questions. And this is the roadmap of the course. So basically today I'm going to kind of tell you why you're here. Like, obviously you're here because you're doing a degree, but why we open a database course in 2026 and what we should learn. How should we learn database in 2026? So the first thing we need to know is, so maybe we'll actually get to this phase next on Thursday. So we'll talk about ER modeling, entity relational modeling. We'll talk about how entities and relationships in real life can be modeled into a schema. And then we'll talk about how to actually map that schema into the database implementation. Because remember, we're mostly interested in the implementation as well as the code. So we learn the model first, and then we learn how to map that model into real implementation. And one thing about implementation and the practical aspect of this course is that how many of you guys have taken at least one CSE course in, CSE? How many of you guys? Okay. And how many of you guys, this is your first CSE course? I'm guessing no. Yeah, a couple of them. Yeah, so this can be used as an elective for some other students doing engineering degrees. So for those students and for people who are new to the CSE system, we have a very good teaching server, so which is the VLab. I'm going to demonstrate today. And for COMP, what's going on here? For COMP3311, we also have the teaching server VXDB02. So you need to connect to that server, and then you initialize a PostgreSQL server on your own, and then you can play with data, and then you can close the server, and then you can exit this, and then you can exit the interface. So that interface is super important for you, and if you know all of the theory, if you know how to code, but you don't know how to use VLab, if you don't know how to use Linux and stuff like that, then you're screwed. And in phase 2, we actually get to learn the basics of SQL. The reason why we chose PostgreSQL is because it is the best, most popular, most widely used open source database out there. And if you learn everything using PostgreSQL, and if you graduate, you work in a company, and then they use Oracle, they use MySQL, it's not a big deal. You can adapt to that in no time. They mostly use the same syntax. So we choose to use PostgreSQL is because it's free, it's open source, and it shares like 90% of the syntax with other databases out there. And in the third phase, probably the second half of the course, we're going to get into the internals of the databases. We're going to talk more about indexing, how to use indexing to improve the speed of the queries, how we process the queries, and how we can manage the transactions. So indexing is basically, we want to store something so that we can reuse it later. And concurrency control is basically, we want to allow different people to work on the same project at the same time in a very good way. So right now, everybody's looking at WebCMS website. So this is fine, because everyone is just reading from it. So what happens if I give access to, I think we have 600 students in this course. if I give out added access to everyone, then within a day or two, this will look very, very different, and everyone is writing on top of each other, so that becomes a mess. So transactional management and concurrency control are all about managing how different people interact with the same database. And in the last week, we're going to do a revision. We're going to revisit all of these concepts, and then give you some pointers and actually give you the database for the exam. So that's enough about what we'll do and what is expected from you. And most importantly, one thing I love about COMP3311, because I've taught other postgraduate courses, one thing I love about COMP3311 is that it has great resources, it has great student support. So we're trying to support students as much as possible, because if you're doing a CS degree, database, data structures, these things are very fundamental. So we want to support students as much as possible, and we would like feedback in real time. So if you say, hey, I feel like I'm not getting any of this because I've been too busy, I'm doing other courses, just tell us on the forum, and we'll arrange more consultations, and yeah, that usually will solve any issue. So these are the resources you have. You have the course forum. We're using the discourse interface, and you should log into that and start asking questions. And we have tutorials. The tutorial starts from next week. So this week, we don't have any tutorials. So it starts from week 2. So don't go to any, every year there are people sending us emails, just like went to tutorial, nobody there. Well, it starts from week 2. And consultations are tentatively scheduled this way to support with your assignments as well as your exams. And also you can, of course, you can send us emails, and we strongly recommend send email to the course email, because all of the course admin and as well as me, including a few tutors, all of them can receive this email. So if you, unless it's like a super personal question, if you want to ask like, hey Jerry, how do you do this, how do you do that? Other than that, you should email the course email. If you want to say, hey Jerry, how do I do research in database after this class, then probably you can send me a personal email. But okay, so we're always here to help you, and and for the resources, like so in week 1, I feel like maybe if you in week 1 this is super confusing for many students, so it's my responsibility to tell you what websites are there. So obviously there's the Web CMS website. So CSE has its own, the Web CMS websites. We put most of the, like 90% of the course content on Web CMS. So here you'll see topic videos, slides, and so topic videos are from previous terms. And here we'll release the assignments as well as the tutorials as well as the practical exercises. So the difference between the tutorial and the practical exercise is that in a tutorial, the tutor will basically give you a recap of the course content of the week, and then it will kind of start with small questions, small problems, and guide you through the problem-solving process. And for practical exercise, you're expected to do that on your own. And if you have hard time doing that, and I am also considering posting some videos about those practical exercises as well, because one thing from that we have noticed is that the practical exercises are super important for the assignments as well as the exams, because that is where you actually practice PostgreSQL in the VLab environment, which I will show you a little bit. And in the course forum, the promise I can make is that if you pop a question on, so any kind of question, there's no stupid question when we're learning, right? And whenever you post a question, we'll try to, the promise is we can respond to you with, we try to respond to you within 24 hours. And most of the times, we try to respond within the same day. So if you ask a question at 4 o'clock, we we'll probably handle that within the day. If you have a question at 9 p.m., then we will probably respond to you by 9 p.m. the next day. And for Moodle, CSE courses, they don't really like Moodle, but we have to use Moodle anyways for recordings. So we'll talk more about it. So you use Moodle for recordings. You use Moodle for online sessions. So people who are watching from online, Moodle is they have to use Moodle. And we have online tutorials, online consultations. And they can only access these via Moodle. And textbooks are absolutely optional. So because we teach a combination of concepts from different textbooks, and we also teach a little bit something that is not in the textbook, like the vector database and retrieval augmented generation. So these are not in textbooks. But most of the times, just sticking with the course material we provide you on Web CMS should be more than enough. And also practice a lot. And I'm planning to release a lot of practices for you guys. And one thing about AI too, so they told us we need to talk about this. So AI is right. Who do you think, who are worried about AI taking your job? Like, I want to know your real thoughts. Software guys? But you're software guys. I'm doing commerce and software. Okay, you're doing every commerce and so and why do you think that's the case? Why?
I've been reading a lot of books, and recently my dad's company CEO was also like, run away from software.
Okay, so there's a myth that the AI is going to take the junior coder's job, but but I don't think that's going to be the issue, because I've used AI extensively in my job and in my research, and at this stage, I feel like it is not going to take people's jobs because it makes way too many mistakes. And one thing about AI taking software guys' jobs is because softwares, they're most easy to verify, because that can create a feedback loop on the AI. So anyways, I think in the era of 2026, AI is both a curse and an advantage. So if you use AI well, it will teach you a lot of things. I learn from AI every day. But if you don't use AI well, you end up not learning anything, because you end up using AI to write every piece of code in your software. And what happens is that so what happens is that I don't think I need to emphasize this too much. What happens is that you don't recognize the code produced by AI, and you just pressed accept. You just put approve, and you don't understand the code is written by AI. So so I've talked with many smart people, smart scientists, and their consensus is that AI and large language model is not something we're going to take everybody's job. It's just another layer of abstraction on top of the hardware, the software, and now AI. So it's just another it's just another layer of abstraction, and we still need to understand how things work to be a good engineer. So what I want to say is that use AI to learn database, but don't rely on AI to write all of the code. Because what happens in previous terms is that, especially previous terms, because that's when the generative AI was becoming very, very effective. And what happened to many students is that they talk to me afterwards. They say, when I'm doing the assessments and stuff, I'm using Claude, I'm using Gemini, I'm using ChatGPT, and it just made me overconfident. I feel like I can solve anything, and in the final exam, they don't have any of this, and they cannot solve the easiest query problem, like create a view problem. So I don't have. So basically, use AI to learn, but don't rely it too heavily. And that's enough with the cross-course logistics. So we should get into business. And if anything before this, if you are confused, you can post it on the forum like right now and see if they'll reply. So now let's really talk about why do we study database and why database is important. Like, why do you guys study database? Why do you think that's important? It stores all the data. Yeah. And how often do you think we interact with databases? Every day, right. So basically at this point, database, especially relational database that we're talking about, the gold standard for databases, we have like 40, 50 years of development under the belt. And at this point, it has become the memory of the civilization. So every interaction you have with technology is basically a conversation with the database, starting with when you wake up, you scroll some shorts on TikTok, and then you tap the Oppo card, you book a flight, you swipe your card, and then you pay for a meal on Valentine's Day, you pay for food delivery, everything. Behind everything, there's a database that you interact with. And when the database fails, the modern world stops. So as software engineers, as everyone should learn about database. So this is a typical day, like a person who gets up in the morning, he goes to the coffee shop, he uses Apple Pay to pay for his coffee, and then it will, and then we need to within the database, it is viewed as a transaction. It needs to say max is down $5, and then the owner is up $5, and then when you're checking in the airport, you're relying on databases to get the flight schedules as well as seat availabilities. And when students are in universities, you interact with database every day. So after the class, you give us course evaluation that's stored in the database, and you get your marks, you get your grade that is stored in the database. And so every interaction is a database query. So what should we get out of this course? So you need to know how to create a database, how to interact with the database, how to insert data into the database, how to ensure the data you insert makes sense. So that is a big chunk of the database theory. So we want a database to be a logically coherent representation of everything we see in the world. So we want to make sure that data we put in the database makes sense. And also how to query the database. So querying is probably like 90% of the SQL code you see out there. So maybe like 10% of the code you ever write will be about populating the database, deleting the database, things like that. And 90% of the code you write will be about asking questions like, what's my mark? Like, how much does my girlfriend, make? Like, do I make more than she, or does she make more than me? And so questions are basically queries. And these are the places you write the majority of the code. And so I'm going to give you a couple of real life examples, like when database fails and what will happen. So this happens very recently, like just last year in October 20th. So AWS is one of the biggest cloud provider out there. We have Google, we have Amazon, and what's the other one? Azure, right? Azure. So if you want to get a job in data engineer or something, in Australia they usually want to get a certificate in AWS or Google Cloud or something like that, or Azure. Like it's best if you got 3 of them, then you're golden. So what happened is that AWS made a huge mistake. So they had their own database. They have a DynamoDB, but what happens is that they didn't arrange the DNS properly, and there was a race condition. And now the DNS is disabled, and people cannot access the internal database. So basically, the database was fine, but the phone book, the entry of the database was gone. And then this created, turned off half of the internet. Like in in the United States, it impacted the most because it was on the eastern side of the United States, and it impacted all of the major websites, including Netflix and including Snapchat. And in Australia, it impacted Slack and Atlassian. So Slack is basically people use to communicate with coworkers in Australian workplace. And also, these three celebrities, they represent different database disasters that are created by them. So what do these guys have in common? They're singers and they're pop culture. Are they all American? I'm not sure. Is Justin Bieber American? Okay. Pardon? Okay. So so they're all. I don't think Kardashian is a singer. I don't think Kim Kardashian is a singer. Yeah, like we wouldn't know, right? Because we're software engineers. Like they're just a bunch of, like they're celebrities. They're all celebrities. They're all celebrities in North American pop culture. And another thing they have in common is that they broke a different part of the database system. So if you learn database, at some point you know the Justin Bieber effect. So when Justin Bieber is like, he's super popular, and when Instagram was not the Instagram today, it was like in the .com era, everybody was developing new websites, new apps, and at that time, the app was very naive. Like it was designed for people with 10 likes and 100 likes. And at that point, people did have 10 likes and 100 likes. And then Justin Bieber came along, and then every time he posts, there are like 1 million likes, there are like 10 million likes, and then he broke the database. What happens is that when you like Justin Bieber's post, what happens is it creates a different entry in the database. So it's a like entry, one like entry, two like entry, three like entry. And for the database to add rows to for the database engine to add rows to the table, they'll need to freeze that part of the table. And when 1 million people are doing that in the same time, we end up with a huge table that is expanding real quick. So by the end of the course, you know that one of the slowest query you ever run is the count query. So in the table, the easiest query you can run is list everything in the table. And another thing you can run is the length of the table. How many rows are in this table? But it turns out that counting the number of rows in the table is very, very slow for good reasons we'll explore in week 10. But at that point, a simple transactional database like this could not handle Justin Bieber. And then they had to change the design of the database. They have to make another feature, number of likes, for every celebrity, so that that number can just keep going up and up without affecting other tables. So this was very interesting, and this was not just a Bieber problem. This happened to many other celebrities as well, but he was the most famous one at that point. And for Kim Kardashian, he also broke the internet in 2014. Some people argue that it is intentional. Some people argue that it is just, they messed up. So basically, they're trying to release a photo of her taken by another great photographer. And the photo is very controversial, as she always do. And what happens is that as soon as they announce Kim Kardashian released a new photo on that website, 1% of all internet traffic of the United States went to that, rushed to that website. And then that website only had like a very small relational database. And here, everybody's just trying to read the post. Right? Everybody's trying to have some read interaction with the database. And then the database froze. The database could not handle that many reads at the same time. And it led to other solutions like caching and handling requests in the concurrent ways. So it really made them redesign the database in a way. So here it made them redesign the database in a more distributed manner, and in the Justin Bieber case, they actually had to denormalize the database. So as we'll talk more, you'll know that in our course, normalization is good, but to a point, you know? And so transactional database, for transactional databases and relational database that we talk about in this course, normalization is great, but at some point, it's not so great that they need to break normalization. And for Taylor Swift, this is a bigger problem than the other two because this involves booking tickets. So when you're booking ticket, what you're essentially doing is that you're clicking on the front end, and then it is connected to the back end database, and the database needs to store your details, your credit card details, your name, and your seat. So basically, this is a bigger problem than Kim Kardashian because there, like, how many Swifties are there? Like, at least millions, right? At least 10 million Swifties are trying to buy tickets, are trying to modify the same database available over there. So each seat can only be sold once, and then they have all kinds of logs within the transactional database, and then it just froze for hours. What happened is whenever you click submit, your website, your interface freeze for hours. And then they fixed that afterwards, but they had to make adjustment to the database. They have to come up with more advanced distributed database to handle these things concurrently. So these are the examples of why databases are important and how the technology is always evolving. But in our course, to understand why this happens we need to understand the gold standard databases, which is relational databases. So what is a relational database? A relational database is basically, we'll talk about this example later. A relational database is basically a collection of tables. A table is the most reliable structured data we'll ever see in our life, and it's created that way so that we can easily access it and we can easily query it. And in the data of AI, tables are great for training and putting labels on things. So, so computer scientists who are working on artificial intelligence, the machine learning engineers, they always love tables. They also love tables a lot because tables is a very great source for training data. So whenever you want to train a model on something, what they do first is that they do some data cleaning to make it a nice table that sits into a relational database, and then they can do training afterwards. So the point of these examples is that relational database is something that we should focus on in this course, and after that, maybe we can explore more interesting, more advanced databases like NoSQL databases and other databases like distributed database that these celebrities caused by these events. So these are some extreme examples, but first we need to focus on how do we model simple data? How do we model tabular data? So before tabular data, there were files. Like if you go to a hackathon, if you don't build have you ever tried building an application without a database? Well, I've tried like many times, and they all worked, but they failed miserably at some point. So I created some applications, and I created some applications for the school, for the university, and then at that point I didn't really know like we should really manage data in the way we do now. So, and the admin team, they didn't know like what to expect. So what I ended up doing is that I have a bunch of Excel files over there and all the other Word documents that are sources of my data. And then based on those data, I need to create reports. I need to present it on the website. And So basically, I use the file system as a database. So what happens when if we just use normal files, a normal file system as a database? There are three problems. The first one is redundancy. So if you don't describe, the one thing about database is kind of like, it's kind of like how you manage money. So if you don't describe how you want to manage money, you lose money. So if you don't describe how you want your data to be managed, you get into all kinds of bugs and problems. So the first problem is redundancy. So if we have information about students, and if we have information about awards, and we have information about your degrees, your marks, they all sit in different files, and they all have different format. And the problem is the same thing is stored everywhere, redundantly. And this is a waste of, first, this is a waste of space. And so wasting of space is not the major concern. So what is the major concern when you store the same piece of information multiple times in different places? So think of your important piece of information you want to remember, like your girlfriend's birthday, or your salary. And what happens, and you just say that you cannot memorize anything for more than 10 seconds. And you need to write it down and you need to store it somewhere. So what if you store one copy in uni, and then you store another copy in your home, and then you store another copy in your girlfriend's house? Do you think that's a good thing? Do you think that's a bad thing? And why? Yeah. You don't know where to access? Well, it's everywhere. I'm in uni, I pick up the note. I'm at home, I pick up the note. I'm at home, I pick up the note. So, good thing or bad thing? Yeah. Just please just speak up. Just speak up. It will be outdated?
Yeah, some parts of the data will be outdated.
Right. The salary part, right? The salary will be outdated, and maybe I'll get a promotion, and then my salary goes up. My girlfriend's birthday stays the same, so that's a good thing. So maybe it will get outdated. What happens then? What happens if it gets outdated?
That's a problem.
Pardon?
That's a problem.
And why is that a problem? Yeah. So the problem is we have old data everywhere, and the thing about database is that we want some consistency. So if we go home and pick up, my girlfriend pick it up and say, you still make 550K a year, I'm gonna dump you. But the fact is that I got promoted to a professor and make much more than that, and she shouldn't dump me. And the thing is that we have data inconsistencies. So just say I do get promoted, I get a huge amount of money, and how do I reflect that? I need to go to every places I store that information and update that. So this happens when you have data redundancy. But on the flip side, what is the good thing about data redundancy? So there's always a trade-off in software engineering. It really depends on what you do and what you do more often. Like if we update very often, we shouldn't have that many consistency. So if we have like different places storing the same piece of information, which is redundancy, what good will come out of it? What good come out of it? Yeah.
If your house burns down, you at least have another copy if you need it.
Yeah, great. So if my house burns down, hopefully not. If maybe somewhere else burns down, but not my house. Maybe her house burns down. I don't know. If we lose one, we still have the other two, and maybe the other two they can just kind of communicate and see this is the correct version of the data. So that's very important. Data recovery, and another thing is that we can do queries much more faster. So if I'm in the university, I can pick up the node and just know how much I make. If I'm at home, I don't need to rush to university to know how much I make. So efficiency is another issue. Efficiency is another advantage of data redundancy. So that is why in the .com era, they kind of slightly broke our relational database. So so right now we're talking about the data redundancy is bad for relational data, but in .com era, when they have like the big data era, they had to slightly relax these constraints for the good you just talked about, for recovery and for faster queries. So, but here we still want to emphasize that for relational data, this is a bad thing. For relational databases, this is a bad thing. And another thing is that another issue is lost update. So when you're a kid, you ever wonder, like, when you transfer somebody money, what happens if it crashes in the middle? Like, you ever wonder about that? Like, I wonder about that all the time because I'm really tight with my money. Like, when people ask me to Venmo them, $20, and they always check with me, did you Venmo me? Did you Venmo me? I would say, yeah, I sent you the money. Why did you push me all the time? Because I think back in their head, they're worrying about that. Somehow I sent the money, but they didn't receive the money. So I wonder that a lot as a kid, but this is a legitimate worry if databases are not designed the way they are right now. So in databases, there is a concept called transaction. For a transaction, the most important property of transaction is it needs to be treated as an atomic unit. So all or nothing. So let's say that I transfer you $10. Then there are two operations we need to do in the database for Commonwealth Bank. They need to deduct the $10 from my bank account, and they need to put that money actually into your bank account. So that's the correct way of doing it. And that should be treated as one transaction. So all or nothing means it is if part of the transaction fails, we should not proceed with the other half, and we should recover the first part of the transaction. Let's say that I send you $20 and deduct it, and I'm down $20 in my bank balance, and then the system crashes. And when the system reboots, what happens is that they will give me back the $20 and they will not send that to the friend. So basically, this is all or nothing. So all means that the transaction went through successfully. Nothing means it didn't go through successfully. There's no partial states for transactions. So if the databases are not designed the way they are, then there will be problems, like you send people's money and then they didn't receive it, but you still lose money. And another thing that we talked about, another problem that could occur for file systems is that concurrent access. So right now, as we have just said, everyone is looking at WebCMS, everyone is looking at our slides. This is fine because everyone is reading the current version and the only version of this database, the only state of this database. So what if everyone, starts doodling, editing my slides at the same time, and it will be a disaster. And if you guys ever collaborated with other people in writing, because have you ever written academic paper or maybe an essay in other courses with other people? No? Yes. What's that? What's that like?
Different updates from different people.
Yeah, different updates from different people, and then you don't fight. You don't fight with them. What if you write something and then they just delete it without telling you, and then they just write a complete different paragraph on top of it, and then you wake up and you see my paragraph is gone. Who touched my paragraph? It never occurred to you?
That's not good.
Oh, okay, I guess you guys are peaceful collaborators, because when we're collaborating, when I'm collaborating with my colleagues, they're all good people, but when we're writing the same paper, we're writing on the same paper, it gets really intense. Like we fight a lot because this is the issue. We don't have concurrent access. We manage everything in one file, and everybody is editing that file, and everything needs to be communicated. Okay, that's a good time to stop, take a break for 5-10 minutes, and then we'll come back and hopefully with more demonstrations. All right, has come back. So we talked about the reason why we cannot just rely on a simple file system. And now we can formally talk about what is a database and actually play with it. So a database is a collection of related data. It needs to be logically coherent and is built for a specific purpose. And for the purpose part, in the next lecture, we'll show how do we model real-world entities into a ER diagram. And then after that, we can map that into the SQL implementation that is tailored for that specific purpose. And examples we already talked about, universities, e-commerce, and banking, everything. They rely on a relational, not everything, like a lot of things rely on relational databases. And it's very hard to come up with an example, a web application that does not rely on relational database. Can anybody have a guess? Like what, other than ChatGPT, like that's definitely, what web application that you use every day that does not rely on traditional database systems? Think of large scale, like everything you, like what do you, if you have a question before ChatGPT, what do you type that in? Where do you type that in? Search engine, right. So search engine, so for search engines, it's impossible to store all that information in the database. So so for Google, they have a PageRank, they have all kinds of information retrieval algorithms to grab that information and rank it and present to you. So at that scale, we cannot really put things into tables and then call it a relational database anymore. So Google is a very good example that does not use a relational database. So what is a database management system? So database management system is basically a piece of software that manages the database. The database is the data, it's kind of like the book stacks in the library, and the DBMS is kind of like the librarian. So if you want to find a book, you don't just go into the library and then just start exhaustively search every corner of the library. You go talk to your librarian, and then maybe he or she will tell you what kind of books you're looking for, and then it will give you some pointers like where you may find the book. And the pointers it gives you is actually kind of like the index built on the database. So it's kind of like the catalog of the book. You read the catalog, and then you know where to find that information. So this is the overview. This is like the overall picture of the database management system. So this is a very complex system. Like within it, the database management systems engine is very, it has like, as I said, it has like more than about 50 years of development, and it has a lot of, it has a lot of knowledge and genius in terms of how to process query more efficiently, how to process query more effectively, how to process them in parallel. So all of that is under the water. You don't have to worry about that. So what we deal with in this course is basically SQL query. So basically we're mostly interested in how to interact with the database. So what we're mostly interested in how to interact with the database so that it can be used in its best power, like so that we can best use the capabilities of the database management system. So, but also in the later part of the course, so the first part of the course will be mostly about up here, the SQL query and the schemas and then the data models. And the second part of the course will be something about things happening under the water, things happening within the database engine, like how it actually handles crash, how it handles different users, multiple concurrency control, how it can be secure, and how to do query optimization, like the same query, the same result, how to do it faster. Like we don't have to understand everything about it, but in order to make use of it the best, we need to kind of know the main idea, the best ideas within the database engine, so that we can take advantage of it. So the good thing about this isolation is that you can have, so basically, we have the database management system, we have the data, we have the database. In this way, we're separating the applications from the data, from the database. So the applications are insulated from the storage details, so that let back-end engineers worry about the databases, and then front engineers can just worry about the business logic and what they really want to present in the front end. And nowadays, many companies, they want you to do both. Like you need to know how to present your website well, maybe write a website in React. And in the meantime, you need to know how to deploy a database on a cloud server that gives information to the front end to present. But in either cases, it makes developing these applications easier. And now we have a standard way of doing it. So back then, we have to rely on messy file systems, or we have to deploy our own databases. Now what they usually do, especially for small to medium-sized business, what they usually do is they just pay for a cloud service, but and then the cloud service, you deploy the database on a cloud service, and that will be linked to your web app or application or website or whatever. But for larger companies, they like to build their own they like to build their own databases because they have the time, they have the money to do it, to be optimized for their own for their own applications. So Google, they have their own database. Amazon, Microsoft, they have their own database, and they can do that, and they should do that because it is better optimized for the application. But for general businesses and for smaller companies, they just don't want to implement deploy a database in a server that sits in their home, and then they would rather have cloud services. So so a relational databases includes PostgreSQL, MySQL, Oracle, and other things. And as I've mentioned, PostgreSQL is the best one in here because it is the most widely used. It's supported in all those cloud providers, Amazon, Google, Microsoft, and it is also open source and free. So basically, in the relational database, everything is organized in tables with strict relationships. Because when we're looking at data, we're looking at the nouns and the verbs. When we look at the world, we're interested in the nouns and the verbs of the world. So the nouns are basically the entities. So we're interested in people, we're interested in iPhones, we're interested in MacBooks. So these are entities. Anything can be, anything that's a noun is an entity. And we're also interested in their relationships, so how these entities interact with each other. So both entities and relationships can be mapped into tables. So we use tables to store information about entities, like students. We store your student ID, we store your name, we store your ZID, we don't store your ZPass, we store your marks, and maybe we can store your relationship with other students, because so Jack and Jerry, friend, Tom and Jerry, enemy, whatever. So we can store relationships between entities in tables in this way. And for relational databases, it's best for traditional applications like the bank, like the university, where data needs to be 100% reliable. It cannot go wrong, and we don't really, yeah, sure.
What's asset compliance?
Pardon?
What's asset compliance?
Oh, that's a good one. So asset compliance is basically related to the transaction management part of the database. So asset stands for four properties: atomicity, consistency, isolation, and duration. So atomicity means a transaction needs to be viewed as a whole, so basically not all or nothing. And consistency means in the database that the same piece of data needs to be stored consistently across its other instances. And independent is the data needs to be, the transactions needs to be isolated from each other. So when you're doing a transaction, another person is using the database, it is as if you're not using the database. So everyone, when they're using the database, it is as if they're the only user in the database, because you don't want to create a table and view the table and then suddenly it changes. So that doesn't make sense. So that's isolation. And durability is that we want to design a database in a way such that when it fails, we can easily recover it. Like transaction is one of the ways we can ensure we can easily recover it, because if let's just go back to the good old bank transaction example. If I transfer you $10 and then it crashes, and then we should make it easy so that the $10 is just given back to me, and then it's not sent to you. And that's an acceptable state of the database. Or it can just make the transaction and then make the transaction to you. You have $10 more than me now. But it cannot tolerate the case where I'm out $10 but nobody received the money. So that's durability. It needs to make sure the database is durable when system collapse. And system, like, there's no database that does not, that's always up there. So maybe they have like 99% uptime, maybe they have like 95% uptime. So we need to design a database so that it is recoverable. And yeah, that's a very good question, and this is something we'll dig a lot more in like week 9, week 10. And so basically, when you need the truth, nothing but the truth, the whole truth, you need like, you need it to be like 100% reliable. Then we need to use relational database. So another thing that we were using relational database for is the brokerage, the trading data. So when you're buying a stock or you're buying an option in a software, they're mostly using relational databases because they're concerned the most with data security as well as consistency. So beyond the relational databases, there are those databases we talked about related to the celebrities. These are called NoSQL databases. So NoSQL databases is not like NoSQL. It stands for not only SQL. So when people don't understand NoSQL, they'll think about, oh, are we going back to the file systems again? No, NoSQL stands for not only SQL. So basically, they're slightly, so for these 4 letters, each of them stands for a property. And for NoSQL, they're slightly relaxing these properties so that they can make things run faster, but like slightly wrong. So that's like the trade-off, and that's something beyond this course. And maybe you can learn that in 9313 in the big data course. And another thing about courses, so if you want to learn about information retrieval, I think there's a course. If you want to learn about big data, there is a course 9313. And if you want to really know the database engine, like how databases are implemented in C, I think it's in C, then you can take the 9315 course. So that actually talks about how we implement that part under the water. So that's a very good course too. And another thing that's very important in 2026 is that we have a vector database. So vector database has been here for a while, but its popularity arises in the last couple of years. So many people don't even know this, but it's super important. So have you guys ever used ChatGPT and then, like, during 2022, do you remember the experience? Like in 2022, 2023, when you're asking questions, like 90% of the time, it's giving you useful information, and 10% of the time, it's giving you gibberish. It's like telling you something not like completely related to your subject. So that is called a hallucination for large language models. So this is a very big problem for AI because a large language model, they rely on billions of parameters to store the knowledge of human beings. So it stores the knowledge of the whole internet. But the thing is that for some specific questions, like the ones we encounter in the assignments, for some specific questions, we don't need the whole internet to answer that question. So a lot of times, the large language models, they make mistakes and they hallucinate or forgot information. So to strike a balance between the interpretability and the expandability of large language models, as well as databases. What they can do is that they can connect large language models to the database. And now the database is not drawing something, putting something out of thin air. He's actually looking at a database and before answering questions. So this is actually called, this is a very important concept in since 2023. This is called retrieval augmented generation. So I think everybody should know that when they're learning about database in 2026. What it does is that it stores different information in the database, and specifically in the vector database. And then you can ask questions. You can propose a question like related to anything, related to a document, related to a book, related to Harry Potter. And then what it does is that it computes the embeddings, basically vectors of these documents, and store them in the vector database. And so basically a bunch of numbers. Each vector is a series of numbers. And we store these vectors in the database. And then when you ask a question, the question gets transformed into a similar vector. And then it will need to compute the most similar vector from that database based on your question. So what it does is that it will pull out, it will get the most relevant part of the document related to your question. And after that, we can feed that part into the large language model, and then the large language model can actually answer questions based on facts, not hallucination. So the result is AI is only as smart as its database. So that's why database is so important in the era of AI, and why vector database is something I want you guys to look at, to understand in 2026. So let's play with it for a bit, and after that we can play with a relational database. So anybody a Harry Potter fan? No, great. At least my expectation is that we should have at least Harry Potter fan because I didn't read the whole thing, so I wouldn't know the good questions to ask. So the reason why I use the Harry Potter is because it's the only free TXT file I can find on the internet easily. So what is this? Can you tell me? Is this a good book? Is this a good one, right? And you know a lot about this book. Let's say I don't know much about this book. And now what I can do is that I put this chunk of text into RAG, into the vector database. I think I just did that. And then it will chop this document into pieces, and then it will create a vector database in the back end. And now what I want you to do is that you want to think of a couple of questions that are very hard to answer unless you have read the book. Can you give me like one example? Like I was thinking, who is Harry's father? But I think that should be that's like too easy. Like what question do you think we should ask? Yeah. What's the job of Mr. Dursley?
What's his occupation? Mr. Dursley, what's his uncle?
Okay. What's the job of Mr. Dursley? Okay. So as you can see that this is the representation of the whole text, and this is stored in the vector database. This is just the visualization of the vectors. And now we need to change the question. And now is asking what is RAG, is RAG relevant? Can you type the question? Can you type? Yeah, I don't. Yeah, can you type the question? Or like any other question you wanted.
Does anyone have a better question? I feel like mine's a bit. No? Okay.
Wait.
Is it working? Okay. Oh, there it is. It's just lagging.
Oh, it's slow because it's computing the
Oh, as I go.
vectors. Yeah, just go ahead.
Okay.
Yeah, just go ahead.
Well, now it's going to be gibberish.
I think we can type it somewhere else and then paste it.
Yeah. Okay.
Can you type it here?
Yeah.
What is? And you know the answer, right? Because
Uh,
without ground truth, we wouldn't know the performance.
Oh, what's
so
his first name? That's a good one.
This should be. It shouldn't be occupation. Okay.
Can I just paste it?
Okay. Okay. Thank you. So as you can see that what it does is that compute a vector representation of the question, and then this is the visualization of other chunks of the text. And what it's trying to do is that it's trying to find the nearest neighbors of this text. So this is a very standard database thing, because in databases we always want to know, we're not only interested in you, we're also interested in the nearest neighbors of you. Let's say you were you won the lottery and you have a lot of money, and then we want to know what are the rows that are very like you. So this is a very standard database thing. And so after this, what it does is that it will get the it will grab the chunks, corresponding similar chunks from the original book, and then along with the question, they will throw all of this into a relatively smart, shouldn't be even a dumb one, like a dumb large language model. It should be able to answer questions like this. So response generation. Okay. Let me response generation. I hope this works, because I've tried this on a couple of other data sets, but I'm not does not mention occupation. Can you try something try something else? First name. Okay. First name. Save changes. Generate. That's weird. Okay. So as you can see, there are still a lot of room for improvement for you to do. So I feel like this is a web interface, and maybe the embedding is taking too long, and it's very hard for it to get the. Let me go back to its let me go back to its default setting. So this is a article about the system. Is an article about itself, and the question is, what is RAG? So the question is, what is RAG? And it finds the most related chunks, and the response. We should have a response out of this, otherwise. So now, okay, now it can grab the text from the original document and answer your question. It is an approach to solve the challenges associated with AI by letting them retrieve information from a database, from an authoritative, predefined knowledge source. So a database in this case. So yeah. So thank you for your patience, and you can play with it in your own time, and we may even release a course a code template for you to play with in later stage of the course. And as we have discussed, PostgreSQL is what we are interested in, mostly introduced in this course. It handles relational data, it supports JSON, and is used by all the big companies. And it is the Swiss Army knife for databases. So if you're new to CSE, you need to know how to connect to the CSE server. So for our course, we have a the teaching server, which is VXDB02. So to play with the database, you need to be connected to this server first. So I'll give you a demonstration of that. So this is actually the web version of the VLab, and I'm going to show you the usual workflow for this course. So basically, right now the host name is just one of the CSE machines, and when you are within the CSE server, you can just do SSH. Can everybody see that? Okay, make it larger. Is this large? Is this big enough? Okay. Okay. So when you're within the CSE server, you can just do SSH VXDB02, and then if you're enrolled in this course, and if you're a tutor or a lecturer like me, you should get in this course, get into this server like this, and then now if you do host name, it will show VXDB02. And now this is where you can actually play with PostgreSQL. So, but if you're from your laptop, if you're using a Linux machine at home, what you can do is that you don't need to use this interface, the VLab interface. What you can do is that you can basically directly connect to this server from your terminal. If you have a Mac, you can open up terminal and then replace that with your ZID, and then it should take you to the exact same place like here. And for every student, okay, these are some personal files. So for every student, we have a folder created for you, and for the purpose of this course, it is stored in local storage. Okay. So when you log into VXDB, it should create a folder, local storage, and then your ZID like that. So if you do that, it will create a folder for you. So let me see if my folder exists. So if I want to go to local storage and then my ZID. Okay, it works. And now at this point, this is empty. And what you want to do is that you want to start some initialization process. And note that when you're doing this at home, like not in this environment, you can definitely install PostgreSQL on your own. But the thing is that it can be slightly complicated for people without the skills or patience. Basically, you need to modify some configuration files to make it work. And the good thing about COMP3311 is that they made it very easy for us to do it in this environment. So basically, they wrote a script in the back end so that you can basically do 3311 PG init. Okay, I spelled everything wrong. PG init, okay. And then it will set up everything for you, and you need to read the reminder here. So now, after you run that 3311 PG init, it has created PostgreSQL related files in your folder, in your designated folder. You can see that if you list it, you can see there is an environment file as well as the PGSQL folder. So every time you log into here, you need to source the environment file and use P1 and P0 to start and stop the server. Hello? Pardon? Yeah, sure. Pardon?
Am I too early?
Yeah. So basically, you need to every time you log into here, you need to source the M file. So you need to source it. Okay, I'm a terrible typer. Source it, and so basically you need to source the M file. Otherwise, you can check the M file if you want. So basically, what the M file is doing is that it's defining these start and stop commands. So after you do that, and if you do P1, Now you have started the server. So the usual workflow for 3311 is that you log into VXDB, you source the M file, you type P1, and now you're connected to and now you have initialized a PostgreSQL server for you to use. And then you can use commands like PSQL, which basically lets you interact with the database. So the first thing we can do is that we can check what databases are there. We have some template, we have some default databases, so these are the database names. And you can connect to the database, and after that, when you're done, you need to do P0, and then the server will be stopped. So always remember to use P0 after your work is done. Otherwise, there will be too many, there are too many servers in VXDB 02, and if you don't kill your server, then when it is near the assignment time, when it is it will cause a lot of problem. So always remember to stop the server when you're done. So I'm going to so let's go back here. Let's start a server again, and we can list the databases, and what else can we do? We can create a database. So we can create a database called MyDB. So create DB. So create DB basically create a database. So it's super easy. And create a database, MyDB. It will create a database. And now if you look at it, MyDB is right here. I feel like this looks weird. And now you can connect to the database you just created. So how do you connect it? You can just use PSQL followed by the database name. After that, you're officially in the shell of the database. So in here, you can do all sorts of stuff. So \d is listing all of the tables. \I followed by some script will run the script for you. So there are two ways to run the script. You can use \I, and you can use PostgreSQL -f and in Linux. So we'll demonstrate that part later. So right now we don't have any. Right now I think we don't have any tables. So so we need to populate the database. So so to do that, we can there are two ways to populate the database from a predefined SQL script. So what you can do is that you can do it in Linux like this way, so PSQL, and then specify the database name, and then specify the place where the script you want to run. The script you want to run is in CS3311, web 26 term 1, prac so 1, my DB SQL. So this is one of the ways you can do that. And another way, so as you can see that it created the tables for you, and also it populated the tables for you. So now, if you go back to, remember, PSQL list is listing all the database, and if you want to get back to the database that we have just created, you do PSQL database name. And now we can see the tables we created. So \d is basically listing all tables, listing all relations. So we have created 4 tables here, and these are the informations about this table. So if you do \d on a specific table, it will give me the information about that table. So a course has 4 columns, and then each column has a type, and then underneath here, you don't have to worry about that much. It's just constraints on the data. These are the constraints that put on the data. So remember I told you there are 2 ways to run in the SQL shells, the SQL scripts. So one of the ways I've just mentioned is like here, I think I just did that. So what I did was this. What I did was this. So this is in Linux. In Linux, I used PSQL, MyDB, and then the script name. And there's an easy way of doing this without typing this part. So what you can do is that you can go to the database and then basically \i, and then you can just type the, and then you can put the script name after that. It will run a script for you. So I'm not going to run it again because it will insert on the same table. So so basically, when you play with the database, first thing you do is list all of the tables, and then you look at each table. Courses, we have 4 columns. Enrollments, or enrollment, I forgot. So enrollment. Enrollment has 3 columns. It stores the course and student as well as the mark. So first thing we do is that we can so this is probably the simplest SQL query you can run on a database. So I hope this is much too much on the first course, on the first class, but I want to get you guys exposed to this as fast as possible. So basically, select everything from courses. We're selecting all of the columns from the courses table. We have the course code, we have the course title, we have the lecturer, and we have the quota. And for enrollment, we can do the same thing. And if you don't want to see that many rows, you can limit it to the number of rows you want to see. So, so this is a typical workflow. And let's see, what else do you need to be aware of when you're playing with it. So at this point, running these queries is fine. So these queries are the majority part. So things that I just wrote like now, they make up like 90% of the SQL code out there. And of course, you can update this data. You can insert more data to it. You can delete the tables, or you can delete the whole database. Let me see if I can delete the whole database. I forgot. So I think it's drop DB. Yeah, if you drop DB, the whole database is gone. So don't do that too often. Like when I was learning about databases, if one thing doesn't go my way, I just drop the whole database and start over. It's not a very good. That's not a very good habit. So just so you know that there is a command like that, but you don't need to use that all the time. So now now that you have dropped it, if you list all of the database again, you see that my DB is gone. Okay. So PSQL. PSQL list. Okay. So now that I'm done, what should I do? I should stop the server, right? So I used P1 to start the server, and now I need to use P0 to stop the server. So I think there is a illustration of what you should do every time you log in. So yeah, basically what I mentioned. So basically, every time you log in, you need to connect to the VXDB server, and then you need to source the end file. That's super important. Like, a lot of times we got questions on the forum, and they say we cannot PSQL not found. I lost all of my databases, but all they missed was they didn't source the environment file, and P1 didn't work for them. And after you source the environment file, you use P1 to start the server, and you do a little bit of work. You can save that to a SQL script, and then call it a day, and then P0, stop the server, go home. So that's the standard workflow. And one thing that you could do if you're really good at using Linux and stuff like that, what you could do is do it in your own risk. what you could do is that you can write an if statement in your shell script, in the login shell script, that says if the host name is vxdb02, then automatically source the M file. So if you do that, if you configure that into your Linux, into this environment, then every time you log into vxdb02, the source file, the M file is automatically sourced for you. But if you don't want to go through that trouble, just that extra command is not going to kill you. So we're just going to do source local storage GID M file. So any questions at this point? Great. So so this is like super important because previously we got like students couldn't access or create databases in week 7 or something like that. Then we really don't know what to do with them. So this offering, yeah, sure. What is VXDB02? Yeah, it's just name of the teaching server. So to give you more context, VLDB, very large database, is a very good database conference in research. So what they do is that they used to have VLDB1, VLDB2, but that's reserved for research purposes. And now they want to still want to use the name, but so they change it to VXDB02, if that explains anything. So in short, it's just a name. It's just a database-related name. Yeah. So in the next lecture, we will talk about why the ER diagrams, the blueprint for database design. So in this week, when you go back home, do exactly what I did just now when the practice exercises, and also tutorial begins next week, and quiz is due next week. And for assignments, the first assignment will be due on about week 5, and the second assignment will be due in week 10. Yep. Thank you very much, and see you guys on Thursday. And for people who celebrate New Year tomorrow, Happy New Year. Oh, okay. So the practice exercise, you don't have to submit them. It's just for your own exercise. It's just for you to practice with. No, they haven't. We are still working on the older test. So they will be released in week 3. How do you do well in this course? I would say play with PostgreSQL as much as possible, because in the lectures we can only teach the most important set of syntax, views, triggers, functions, and stuff like that. But there are some nuances that you can use, but we didn't teach, and you can definitely explore them. Exam. Oh, I mentioned the exam is going to be like code heavy. So the exam will be like code heavy. So basically, the first few questions will give you like a theory question, the concept question, and then we have like, and then the majority will be code based. You will have access to auto tasks and stuff like that in the CSC invigilated exam environment. So basically, you plus. The coding part is SQL. SQL as well as Python.
What do you do with SQL?
Yeah, queries. Queries will be the majority part, but we'll ask you to write other things like maybe triggers, maybe functions, maybe, and you have a database to play with. Definitely need to pack up before I keep. Yeah. What else? Yeah.
I just wanted to ask, can we use something like Table Plus for this course?
Mhm.
Like I use MySQL Workbench when I work separately.
Mm-hmm.
So if we are working on local, is it advisable that we can use something like Table Plus?
What the,
You know-
I'm not familiar with Table
it's like
Plus.
basically a UI where you can see your tables in a like much better way. It's like, but
If you can do that, if you can do that in your own computer, you can definitely do that. But we recommend you use the VLab environment for testing. But if you want to do that in your own computer, like locally, that's
but
definitely
we
fine.
won't have the access for the exam, right?
Pardon?
For the final exam, we won't have the access for any extra.
Table Plus, of course. Like, of course we can. For the final exam, where it will be in the VLab environment, and you cannot use that. You cannot use the internet. I think.
Yeah.
You can use PostgreSQL menu. You can check the menu,
Yeah, no.
and
problem.
but this is. Oh, that's a complex question. Send me a personal email then. Let me pack my stuff first. You were saying? Great.
Are you all here in the right class? 9024? Good, good start, good start. Why are you so early? I thought I was getting early. Is it a bit stuffy here? Yeah, I think, yeah. I mean, I think air conditioning is on. Let me see. Yep, I think I just turned it on. Come in. Welcome to your AI browser. How topical is that?